Okay, this tutorial is on how to convert between molecules and mass. There's several different ways to approach this problem. I'm going to show the way that I feel that most students are comfortable with. So as always, we start by writing the given information. In this case, it is 3.6 times 10 to the 26th molecules. Okay, so we know from before that 6.02 times 10 to the 23 molecules equals 1 mole. And we also know how to determine the number of grams in 1 mole. In this case, for carbon dioxide, carbon has a mass of 12. Each oxygen has a mass of 16, so the total mass is 44 grams. So 44 grams of CO2 equals 1 mole. Now, if we know that 6.02 times 10 to the 23 molecules equals 1 mole, and 44 grams of carbon dioxide equals 1 mole, that would mean that 6.02 times 10 to the 23 molecules is also equal to the molar mass. So equals 1 mole equals 44 grams. Okay, keep in mind this number varies. The number that would go next to grams is determined by the atomic mass that you're dealing with, or the molecular mass. So in this case, it was CO2, but if we had a different compound, we might have a different mass here. Okay, so just as before, once we write down our given information and we're multiplying it by a conversion factor, I'm going to write down the same units on the bottom that I have on the top. I do that because I'm trying to get rid of molecules. The question is asking for mass, which is also grams. So I'm going to write the unit that I have on the bottom and the unit that I want on the top. Okay. When we're doing our conversions, okay, 6.02 times 10 to the 23 is always the number that goes next to molecules. That's how many molecules is in a mole. That would be, this would be the mass of 6.02 times 10 to the 23 CO2 molecules. In other words, if I had 6.02 times 10 to the 23 carbon dioxide molecules, then it would have a mass of 44 grams. Okay, so molecules cancels out. Okay, if you're not sure how to use scientific notation on your calculator, I recommend canceling out the exponents. So since I have an exponent up here and an exponent down here, if I could get them to match, that means I could cancel them out. So right now I have 26 up here. I'm going to change that to 23. Okay, so the difference there is 3. I made this number 3 smaller, so this is going to get 3 decimal places larger. So 1, 2, 3. Okay. I'm going to rewrite that down here. So it's 3, 6, 0, 0. Okay, so 3.6 was moved 1, 2, 3 places. Okay, I changed this to 10 to the 23 so I can get rid of it. It's gone. Right, and I'm multiplying that by 44 grams. Okay, and we still have this 6.02 on the bottom. Okay, so I'm going to punch that into my calculator. I have 3,600 times 44 divided by 6.02. Got a very large number here. I have 2,631.2.29. Okay, if we look back at the given information, I had 2 sig figs. So I'm going to go ahead and round my answer to 2 sig figs. And that will give me 2,6,0,0,0. Okay, I want 2 sig figs, so I look at the third number. It's less than 5. So that rounds this down to 26,000 grams CO2. Okay, so remember, we put whatever units we have on the top go on the bottom of the next step. We put the unit that we're looking for on the top. Okay, 6.02 times 10 to the 23 is the number of molecules in 1 mole, and this would be the mass of 1 mole. All right, let's try another one. Okay, how many molecules are present in an 88-gram sample of carbon dioxide, CO2? So I have 88 grams of CO2. I have grams on the top, so I'm going to put grams down on the bottom. Okay, these are always going to match, trying to get rid of grams. And I'm looking for molecules, so I'm going to put molecules on the top. Okay, we already solved for the molar mass in the previous problem. The molar mass of carbon dioxide is 44. Okay. And molecules is 6.02 times 10 to the 23 according to our conversion factors. 6.02 times 10 to the 23 molecules equals 1 mole equals the molar mass. So what we're going to do is we're going to start by ignoring this exponent. Okay, we're going to come back to that later. So what I'm going to do is I'm going to multiply 88 times 6.02 and divide by 44. So I'm going to rewrite that over here. 88 times 6.02 divided by 44. And I get 12.04. All right, so now we need to remember that we have to include this exponent. Okay, remember that 6.02 times 10 to the 23rd is an extremely large number. We looked at some examples of how large that was in class. So if you're multiplying this by this huge number, we know that we're not going to get an answer just like 12.04. So in other words, when you are converting to molecules, you need to remember to include the exponent. So now we have 12.04 times 10 to the 23. This is not correct scientific notation. So what you need to do is we need to move the decimal into the correct place, which would be after the first digit. So 1.204. And if this number gets one place smaller, this one will get one place larger. Then if we take significant figures into consideration, here we have 1.2 times 10 to the 24th molecules of CO2. So in other words, if I have a sample of carbon dioxide that has a mass of 88 grams, so I take that sample, I put it on a scale, I get the number 88, that means that I have a total of 1.2 times 10 to the 24 carbon dioxide molecules present.